Every square inch of the sun hides a spinning vortex that rewrites solar physics. The sun's surface is covered in millions of invisible tornadoes we've never seen before. In April 2024, researchers at the Max Planck Institute analyzed data from the Solar Orbiter spacecraft and found something impossible. The sun's photosphere is blanketed in compact swirling vortices, each smaller than Texas. These aren't the giant coronal loops we filmed for decades. They're microscopic tornadoes, spinning at 25 kilometers per second, packed so densely that millions exist at any moment. The team used polarimetric imaging, measuring how light twists as it passes through magnetic fields, to reveal structures 10 times smaller than previous detection limits. Lead researcher Chitta called them the smallest magnetic whirlpools ever observed on the sun. They spin for 30 to 90 seconds, then vanish, replaced instantly by new ones in an endless cycle. But why does the sun need them at all? For 80 years, solar physicists have faced a paradox. The sun's visible surface sits at 5,500 degrees Celsius, yet the corona, the wispy outer atmosphere, burns at 1 million degrees Celsius. That's like standing farther from a campfire and getting burned worse. Energy has to flow upward somehow, but convection can't explain it. These newly discovered vortices might be the missing pipeline. Each whirlpool acts like a magnetic drill, boring through the photosphere and channeling energy into the corona through a process called Alfvén wave heating. When plasma spins inside twisted magnetic fields, it generates waves that propagate upward and dump kinetic energy into the corona. The solar orbiter detected temperature spikes of 100,000 degrees Celsius directly above vortex clusters, the first observational proof the mechanism works. And that's only half the mystery. The vortices don't appear randomly. They organize into networks following the sun's underlying magnetic field lines, like iron filings on a magnet. Chitta's team mapped 4,600 individual whirlpools across a single 300,000-kilometer patch of photosphere and found they cluster near magnetic flux concentrations, regions where the sun's dynamo pushes field lines to the surface. Stranger still, the vortices communicate. When one collapses, neighboring whirlpools briefly accelerate, as if the magnetic tension redistributes. The implications cascade even further. These vortices don't just heat the corona, they may seed solar wind, the stream of charged particles that batters Earth's magnetosphere and triggers auroras. Millions of invisible tornadoes, each smaller than Texas, spinning across the sun's surface every second, and we only just saw them in 2024. They might solve the coronal heating paradox, rewrite stellar models, and predict the next solar storm. Subscribe to @BrainyWizBros for more cosmic revelations, and watch our deep dive on why the sun's core rotates faster than its surface. Subscribe @BrainyWizBros for more stellar secrets.